Good morning, students. Our today's topic in the subject of chemistry O levels is the hard water. So today we will read the reasons why the water become hard, the types of the hard water, that is soft and permanent hard water, and then we will read the different methods to remove the hardness of the water. So concentrate yourself. This is the subtopic of the topic water. So we are going to start. In hard water, you will find it difficult to make a leather with soap. So this is the sign of the hard water. So leather is not easily made in the hard water. Bits of the white scum will float around in the water when you use soap. However, it does have its advantages. So there are some advantages and disadvantages of the hard water. So this is very important topic as far as your paper is concerned. So this part comes in the paper frequently. The disadvantages of the hard water is difficult to form leather with soap. So more soap is spent. So more soap is a waste. So the advantages, some people prefer the taste. So some people like its taste. So the advantages come forms in a reaction which wastes soap. So this is the wastage of the money. But the advantages, calcium in the water is good for the children's teeth and bones. Disadvantages, scale, a hard crust forms inside the kettles. You have seen when the kettles are used frequently, more and more. So a scale that is called a hard crust is formed inside the kettles. This wastes the energy when you boil your kettle. So more energy will be used in boiling the water inside the kettle. But the advantages helps to reduce heart illness. The persons who use hard water to some extent can reduce the heart illness. The disadvantage is hot water pipes fur up on the inside. The scale formed can even block up pipes completely. So that may be dangerous. So the pipes may be blown up. So, but the advantage is some brewers like hard water for making beers. They say that the beer's taste who is made by using the hot water are of very good taste. And other advantages are coating of the scale, lime scale inside copper or lead pipe stops poisonous salts dissolving into our water. The next topic that we are going to read is what makes water hard. If your water supply has flowed through chalk or limestone, calcium carbonate, it will be hard. Other rocks which contains calcium or magnesium also cause hardness. So the main reason for the hardness of the water is the calcium and magnesium ions. Gypsum calcium sulfate is an example. So here you can see here is a gypsum rock. So when water flows through it, the soft water becomes hard water because the calcium and magnesium ions from the rock dissolves into the water. Calcium or magnesium compounds dissolve in water, make it hard. Calcium sulfate is slightly soluble in water. When a river flows over gypsum, it dissolves some of the rocks. Therefore, the calcium gets into the water, which causes the water hard. However, calcium carbonate is not soluble in water. Water does not dissolve chalk or the limestone rock. People often think that rainwater is the purest water you can get, but this is not true all the time. This isn't quite true. On its way down, gases dissolve in the rain. One of these gases is the carbon dioxide, a weakly acidic gas. It's the bubbles you see in the fizzy drink because the fizzy drinks contains the carbon dioxide. So when you open the cap of the fizzy drink, you can see the bubbles. This is due to the carbon dioxide gas which is dissolved in the drink. This weakly acidic solution dissolves away the limestone or chalk. So hydrogen carbonate when react with the calcium carbonate, it makes calcium hydrogen carbonate. So this is dissolves away the limestone. Look at the state symbols in the equation above. You can see that the calcium hydrogen carbonate formed is soluble in water. Therefore, the calcium gets into the water, making it hard. So this is how carbon dioxide make the hydrogen carbonate. Hydrogen carbonate react with the calcium carbonate, making it calcium hydrogen carbonate, which is soluble in water. So that is how calcium is dissolved in the water to make the water hard. The next thing that we are going to read is removing hardness. You have now seen how hard water is formed. The calcium or magnesium ions in the water is present as charged particles called ions. The most common cause of the hardness is the calcium ion, that is Ca2+. These calcium ions react with ions from the soap, sodium stearate, to form the scum. So calcium ion react with stearate ions to form calcium stearate. That is, hard water plus soap forms the scum. So this is the equation of the scum, how it is formed. If we can remove these calcium ions from the water, we will get rid of the hardness. So there are two types of the hardness which we are going to read now. The first one is the temporary hardness. Do you remember how calcium ions from the insoluble calcium carbonate gets into the hard water? Limestone reacts with the acidic rainwater. It forms a solution of the calcium hydrogen carbonate, which is soluble into the water. Calcium ions are now into the solution. This is called temporary hardness. When this solution is boiled, calcium hydrogen carbonate breaks down and the process is reversed. Again, the calcium carbonate is formed. So it turns back into the insoluble calcium carbonate. Therefore, calcium ions are removed from the water. And here is the equation. So the temporary hardness can be removed just by boiling the water. The calcium carbonate formed is the lime scale you get inside kettles and hot water pipes. So these are dangerous because they block the passage of the block the passages. Temporary hard water can be softened by boiling. However, not all hard water can be softened by boiling. Other calcium compounds such as the calcium sulfate from the gypsum are not removed by boiling. These form permanently hard water. So look now, from the gypsum, calcium sulfate dissolved in the water, that makes the water permanently hard. So the methods now we are going to discuss removing all types of the hardness. Either it is soft temporary hardness or the permanent hardness. We have seen how we can soften temporarily hard water by boiling, but permanent hardness can also be removed. Permanent means forever, but all types of the hardness can be removed from water. The first method is washing soda. So when washing soda is dissolved in the hot water, so look now, when you add washing soda to hot water, the calcium ions are removed. These react with the carbonate ions from the washing soda. This forms insoluble calcium carbonate. So look now, the calcium ions that are present in the hot water react with the carbonate ions and making it calcium carbonate, so which is soluble in the water. If the solid forms when two solutions are mixed, it is called precipitation reaction. So calcium carbonate that is made is insoluble, so the hardness is removed now. Most modern washing powders have their own water softeners added. The next method that we are going to read is the ion exchange column. This method is more suitable for large scale treatment of the hot water. So in this, the ions are exchanged. So in ion exchange column, actually sodium ions are present, and when the water containing calcium ions are flowing through it, so the calcium ions are replaced by the sodium ions, and water is collected in the bottom container, and the calcium ions are fixed into the resin So this is the method that is called ion exchange method, and here you can see the figure. So look now, the hard water in, that is containing the calcium ion. Here are resins. So calcium ion in hot water, calcium ions get stuck in the resin. So all the calcium ions get stuck in the resin. And ion exchange resin, here are actually sodium ions. So when all the sodium ions have been washed out, so water containing the sodium ions are now come into the containers. You can see sodium ions are here. So sodium ions are replaced by the calcium ions. The column can be recharged by running salt water, sodium chloride through it. So soft water out. Sodium ions replace calcium ions to soften the water. The column is filled with resin which holds plenty of the sodium ions. So this is the explanation of this procedure. The column is filled with a resin which holds plenty of the sodium ions. Hard water goes in at the top. On the way down, the calcium ions are swept. For sodium ions, the calcium ions get stuck on the resin, and sodium ions which don't cause hardness come out in the water at the bottom. And here is the reaction. Calcium ions plus sodium permutate and becomes sodium ions plus calcium permutate. So calcium ions are get stuck in the resin then. Permanent hardness is caused by dissolved calcium sulfate and magnesium sulfate. So this is the reason of the permanent hardness, and temporary hardness is caused by the dissolved calcium hydrogen carbonate. So remember this point. This is very important as far as your paper number 1 and 2 is concerned. So read again. Permanent hardness is caused by dissolved calcium sulfate and magnesium sulfate, whereas the temporary hardness is caused by the dissolved calcium hydrogen carbonate. Okay, testing for the aqueous ion. So the metal ion, that is metal ion and result of adding sodium hydroxide solution. So when metal ion, that is copper, is adding with sodium hydroxide ion, so pale blue precipitate of CuOH twice is formed. When iron ion, that is Fe2 plus, is adding with sodium hydroxide, FeOH twice, green dirty precipitate is formed. When iron Fe3 plus ion is adding with sodium hydroxide ion, rusty brown precipitate of FeOH thrice is formed. This is actually paper 4 question. When aluminium Al3 plus ion is adding with sodium hydroxide ion, white precipitate of AlOH3 which dissolve in the excess sodium hydroxide is formed. Magnesium, when Mg2 plus is adding with sodium hydroxide solution, white precipitate of the MgOH twice is formed. And when calcium, that is Ca2 plus ion, is adding with sodium hydroxide solution, white precipitate of CaOH twice is formed. So this was the lecture, students. I hope so this will be much more easier and interesting for you to understand and learn now. So read this lecture again, understand it, learn it, and make your notes. Thank you so much.